Hello, welcome back to the fourth part of the discussion that we have been on the midterm question paper. Now, let us look at the question 9. This is a very simple question where you are expected to answer the description or a short two line, three line description on what does this p thread join instruction or not even instruction, it's a system call. What does it do? What is the purpose of those two arguments? Now, to just answer this question, pthread join is the block call, a system call, which makes the currently executing thread to wait for the thread whose ID is being passed as a first parameter to execute a pthread exit. So that means it is waiting for the ID to be terminating with the call to pthread exit. That means that the ID is a valid thread ID, of course, and then it is either being running is either it is running or it has already exited. If it has already exited, this function will come out immediately, pthread join. So you can make it a short description which key of this particular question will be giving you how to write a short description of a question like this. And what does the result mean? It is a pointer to the status which has been returned by the this thread when it executed the pthread exit. It passes a pointer. If it is a non-null pointer, then it may have a pointer to some result which will be available in this result. So basically, the code a thread which is executing this pthread join will will get blocked till the ID, which is nothing but a thread ID, which if it is currently executing, it will wait till this particular thread ID stops and executes a pthread exit and exit out of the execution. Okay, comes out of the execution. So that's a real short summary. Maybe let me show the answer key that you are supposed to maybe write. These are all other questions which we'll be discussing soon. So let me say that the thread calling this routine, the pthread join, gets blocked until the thread with the ID passed to it executes pthread exit. The result variable will have the result or status returned by the exiting thread. That's it. Okay, two line explanation for this. Now, just to make it clear, let us look at the code. Okay, let me just show you this code it was done during lab 7 experiment 1. This code will also be shared, which has already been shared as a part of the lab, and we know that it has to be executed using this command, and lpthread is a library and it is a reenter function and executable name is exp1. Now we will first understand this code and then run it once. Okay, now two thread functions are there. That means it is going to create two threads, and then there is a message which is common message. Okay, and then there is two other messages which are also global data. Okay, it's a global pointers which are initialized with the string. Now we have the result, which is a variable declared locally, which is to hold a pointer which is being returned by the exiting thread. Okay, this is only a placeholder, so this can be a local variable and it can be only accessible to this particular main thread, but the pointer what it is holding, the address what it is holding, can be something which is within the process address space. Then it will be easy to print it. So it is as a placeholder. Now we have created a placeholder, a pointer to keep the result which is coming from the thread which is exiting. So we are creating a pthread create, which I have already explained in the earlier question on part A. We are passing the address to thread ID, which has also been created here, a local variable of type pthread t, which is a built-in type of pthread library. This is, we are passing a pointer so that when this pthread create is successful in executing this call and it successfully creates a thread, it writes the new thread which is created in this particular variable. So that's why we are passing the address so that it can be written into. and this is the attribute variable which we are not interested in passing any attribute. So it is going to create a thread with a default attribute. It is going to ignore this second parameter. Then thread function. So we want it to execute a thread function 1 because this is a thread 1. Okay. And then we are sending a specific message which is a message 1. So as the thread is part of this main process, main thread, and it has access to all the data area. So this particular pointer which is being passed is also in the address space of the main thread. So it is accessible to the thread. So it can actually receive the parameter and print it. So what are we saying pthread create? When you create a new thread, make sure that you call this function, and this function needs a parameter because this is the signature of the thread function. So what is to be passed? I am giving you this value. Please pass this while you invoke that function, because we are not going to invoke it. It is going to be invoked by the OS when it creates successfully a thread. That means we are given the piece of code to be run by the newly created thread. Now, if the status is non-zero, then error, exit immediately. We can't do anything further. Then try to create another thread and initialize the pointer or thread ID in this address and call a different function and different message. So all are done. Main thread has created two threads successfully, and they are all running now. One is running this function, other one is executing this function, thread 2 function. Now what is the main thread going to do? Because they are all parallelly running, so you don't need to worry about what those threads are doing. But let us continue with what this main thread will do. It will print some other messages, and then I'm going to sleep. So it is going to sleep for 5 seconds. Then it's going to execute pthread join. Now this is what I explained you just now. We are passing the we are going to wait for the thread 1 to stop executing. So after 5 seconds we come here and then wait for thread 1 to execute a pthread exit. Okay, that means it is terminating by calling a pthread exit. While calling the pthread exit, it is supposed to pass a pointer, and if it happens to be a non-null pointer, then it will be anyway whatever value being passed by the pthread exit will be here in this variable. That means thread 1 result, we are sending the address of that so that it can be written into the pointer that exiting thread is as given to the library is written by the library on this variable. Remember, the calling thread is not writing directly. It is saying that I am going to exit and sending a pointer, a message. That pointer, whatever it is passing, is written into this particular variable, and it wakes up. Main thread wakes up, and if it is successfully woken up, that means that thread really whatever ID you have passed was a valid ID, and with that ID there is a thread living in this world, and either it has terminated earlier or it is going to terminate. Whatever it is, it will wake up when it terminates with the call to pthread exit. Please remember that. So if it has already exited calling pthread exit, the message will be available in the library, which will be written by the library, written to this variable, and it will wake up immediately, the main thread. If it is not, then main thread will be blocked until the thread exits. So once that is done, it is printing whatever result has been passed. Since we know that the thread result is a character pointer because it's passing actually a string, we are typecasting to a character star and printing it as a value, what has been returned by the thread which exited. Then we wait for the second thread, then print it, then it will run forever. Okay, that's the main thread doing. Now what is the thread 1 function doing? We passed a string, thread 1, thread 2, right? That pointer is being received here, and it is printing whatever has been passed while creating, and then it sleeps for 5 seconds. See, remember, this is sleeping for 5 seconds, and our main is also sleeping for 5 seconds. That means it may be within the same time it may wake up, or there may be some gaps in between them, and immediately after waking up it is going to print something. I woke up, and I'm going to say I'm going to copy some message into this message variable which I have already allocated some space. Okay, we have allocated a long this message pointer is there, array is there. Actually it's not a message pointer, remember, it's an array. So we have created a message array of this length. Okay, it is there as a global database, and into that address it is copying a smaller thing, so it will it will fit into that larger array. So you need to understand that we have created a character array, and we are passing the character array the initial starting address, and earlier it was filled in with some other string, some other values, and now we are overwriting it with this. Who is overwriting it? This thread 1 is overwriting it. Now after it writes into it, and it is going to pass the address of that to the pthread exit, or it doesn't actually pass because it's a global message. I'm not passing that value. Actually I will print it here. If you see here, message is also printed. Okay, after every thread joins, message is printed. Okay, after thread 1 joins, message is printed. Then in thread 2 join, after thread 2 join, message is printed. Now when the output comes, you will see that the same message array is going to hold different values. Why? Because it's a one single location which is there reserved for holding some values of characters. Initially it is having this value, then when thread 1 exits, it is going to have a different value which is being copied into thread 1 bye bye, and then when it exits, it says different no string it is passing. Thread 1, thank you for your CPU time. Okay, it is very gratitude it has, so it says thanks for your CPU time, because main thread only created this thread, right? It has some gratitude for the main thread, so it says that no, you gave me a chance to run on the CPU, so bye bye. And then see the order in which it has been structured. Now thread 2 is created and thread 1 is created almost one after the other, but thread 2 is going to sleep for 10 seconds. So it is sleeping much more than the thread 1, double the time. So it is going to wake up little later. By the time main thread would have printed the value, because 5 seconds is enough for this thread to get a chance to run, assuming that the scheduler is scheduling this main thread also. So it because the thread 1 is exiting first, here thread 1 is exiting first, it would have come here and it would have printed the message written into this array by thread 1 on exit. Okay, understand that. If you see the flow of output, you will be able to appreciate what I am saying, trying to do now. Then what happens? Thread 2 is waking up after 10 seconds and it is going to copy into the same array. Now it's going to give some other value, some other characters, and it is copying it and saying, I am saying bye bye. This is passing on the string. So this string is part of the code area which I mentioned, and that pointer is still valid pointer. So when pthread join wakes up with the result, that pointer address is accessible to the main thread also, because they are all same family, right? Main thread and the threads are all in the same family, and the strings of are all in the code area, which is also accessible. The code and data I said is accessible, but string, any string is also part of the code area normally, or it may be a read-only data. It depends on how the program compiler is accessing the string, but most likely it is going to be part of the code area. But it is accessible anyway. It's not going to be on the stack of the new thread which is created. So that result is also accessible to the main thread. So that's the beauty of this code, where you have the same data array or a character array overwritten by multiple threads at different point in time. So you are able to print it on the screen. Okay. So let us just before we end this lecture, we'll just print it and see how nicely it is coming up on the screen. Okay. So let us see. This question is number 9 and we have to compile it. So -4 question 9, then what do we have to do? Q9 model dot C minus D underscore reentrant. Okay, and then remember to pass the library, because we are using pthread exit, pthread join, okay, pthread create. Those are all the functions which are defined in this library. If you don't give this, it will say that unknown functions. Okay, so all the jobs whatever we are saying, holding the process, they are all done by the pthread library with the help of the OS. So you don't think that pthread library is doing it on its own. It has an interface to the OS, and it knows what are the OS system calls to be called to make a thread to get blocked, or to make the thread to while exiting, getting the address of whatever it has passed, all that is captured there. Okay. Now we have successfully compiled it. So let us just print it. Now I will show you. Let us run it. Q9. Okay. Now 5 seconds main is waiting. Okay. Now thread 1 has woken up after 5 seconds. So I'm sorry. Thread 1 has woken up. Thread 2 has woken up now. Okay. 5 seconds. Okay. Okay. Thread 1 also has woken up, but it is still alive. Now, what is happening here? See, initially the message array was having this welcome message. Period of the main process is so and so. Thread 1 is created successfully. Argument passed to me was high thread. See, when the thread 1 is now, this is being printed by thread 1, this is being printed by main. Thread 1 created successfully, main says, and then it goes on to create a thread 2. By the time thread 2 is getting created and thread 2 created successfully is printed, the thread 1 is getting a chance to run, and because it's a multi-core laptop I have, so thread 1 is running in parallel and that message is coming. Why is that main thread message as well as thread 1's message, thread 2's message are all coming to the same window or same terminal? Because they are all tied to the same terminal. Tied means in the sense all the std in, std out and std error are I told you that they are all standard input output error channels, which are nothing but a file descriptors of 0 and file descriptor 1 and 2. std in is file descriptor 0, std out is file descriptor 1, and std error is file descriptor 2. They are all treated as a file, like a stream of characters which are can be sent to it or can be received. It can send it out to the terminal. So any process which is created will have a default file descriptors where any printf you write in that particular program is going to that std in. Now, whenever you are writing into your std in means a printf will go to std out, and std in is if suppose you are waiting for scanf. If you are waiting for some character to be typed by the user, then the window will be getting blocked for scanf. That means whatever you type on this terminal will go to that process. So how is the terminal? What is happening is communicated back in the OS, in the process which is running in the background. It is because that whatever process I am creating here, and I am creating a Q9 process, and that in turn is creating multiple threads. They are all because they are all created by the same process, and they are all happening in the same terminal, from the same terminal. All of them share the same terminal. Now all the messages coming from them based on the buffering as well as time at which they are happening, they will be overlapping with each other, but it will not garbled out the printout, because the entire string will be printed, but one string from one printf from one particular process can be intermixed with the other process. Now these messages you will not see the same thing when you run it on your laptop or in your Linux, because the scheduling sequence may be different. We are not controlling the scheduling. OS is deciding about which process will run first, and in this case main is first running and thread 1 is created successfully is coming in the main after the thread 1 is created, but thread 1 messages have not come before that main is coming. That means it is given a priority to the main thread to give the message out. Then thread 1 message is coming. I am going to sleep for 5 seconds, and then during the time main has created the thread 2. So I created the thread 2 successfully. Now main is saying I am going to sleep for 5 seconds. Both are saying that I am going to sleep for 5 seconds. The order exactly when they went to sleep depends exactly on where they ran and which CPU they ran, and whether they were one may be ahead of it, other can be behind, but we cannot predict it. Now thread 2 says I got an argument passed to me as high thread 2. So now thread 2 got a chance to run. Now thread 2 says I am going to sleep for 10 seconds. Now till this point, at this point what happens is 5 seconds have to elapse. Till then you will not see any interaction or any messages coming on the screen. That's what we saw. It was just waiting. And then thread 1 said that I woke up 5 seconds. I'm going to call pthread exit with a message. Now this message to main thread. This message is a common buffer I explained to you, which is getting written into. Okay. now earlier it was holding this message. Now this message, okay, this entire message was there in the message buffer. Now it is going to write something else, which is that we saw that thank you for CPU time. This is actually pthread exits thing, going to wait for thread 1 to finish. Main is saying, and then thread 1 join message after thread 1 writes into it the thread by what by. So this is the message it is writing in the message box, and this is the message it's returned as a part of the pthread exit. So it is coming here, that pointer is accessible to the main thread, so it is printing that thread 1 joined, that means thread 1 exited, okay. And it returned me in the pthread exit call, it returned me this string, and then on the message box I am printing again message, and it has overwritten on that message. Now you may wonder that how remaining characters are not printed coming, because when it wrote the thread 1 bye bye, it also terminated it with the null. So printf will not go beyond that, okay, even though remaining characters are there. Then main is saying I'm going to wait for 2 seconds. Sorry, not wait for 2 seconds, another 5 seconds actually, based on the thread 2 when it is coming out, because it is going to sleep for 10 seconds, right? So thread 2, it is waiting for thread 2 to finish. Now thread 2 says 5 seconds have elapsed till from this 2 messages, okay. Now thread 2 says I am woken up 10 seconds. I woke up after 10 seconds. I'm going to execute to pthread exit, but I'm going to send some message which is thank you thread 2, thank you for CPU time, and it has already returned the message. Now thread 2 bye bye. Now thread 1 bye bye was there in that same location. Now thread 2 bye bye is returned after some 5 seconds. So because they are all writing at different point in time, we are able to see them without getting garbled. But if I make them write simultaneously, you may get a garbled output if they happen to write at the same time, which is very likely as well as maybe mostly unlikely too. Now main is saying I'm going to wait forever while one. So if I go to the other window and let me clear all of them, and ps minus all, if I do, I will get Q9 process 2437. 2437 is the PID it meant. It said that my process main thread process ID is this. Now what I'm going to do is I'm going to just while the uh, main thread is waiting for thread 1 and thread 1 to exit, we'll see what happens, okay. Now let me see control C. So it has terminated. Now I can come and see here whether that thread is still alive, that process is still alive. Q9 is gone now, okay. Let us clear it. Now let us run it again, ./Q9. Let me run it now. Immediately I will come here before. Now see two. Okay, I have to be a little bit much faster than what I am doing, otherwise I won't be get able to. So let me keep another command -t -p, okay. Let me give a illegal command here so that I will have it in my buffer. So okay, so what I will do, I want ps let me write it, ps minus t minus p. Let me keep it in the buffer. ps minus all, let me keep it here, okay. Okay, so I'm just trying to be faster. Let us see whether I'm able to do it, just because I need to know the. Now ps all I don't have to do because I have the okay, let me keep it ready here. Let me keep it ready. I have to type in as soon as I get the okay. Okay, let me clear it. Let me keep it this, okay. Now I am going to run it 2459. Oh, I'm not fast enough, but at least I can show you there are two now. Why? Thread 2 is still running, but it's PPID, and the PID is 2459, and it is thread ID actually SPID is, they are different, okay. This is a parent ID 2459, which is 2459, okay. So you can see that both of them are having 2459 as a PID, whereas my main thread, this is a main thread because I typed it after the thread 2 exited. I have only thread 2 here, otherwise 3 entries I would have seen. So let us try it again. Once again, I'll give me a chance. Okay, let me clear this. Okay, 2464. Okay, I managed it. Now you see 2464, 2464 are the parent ID, and these two are guys are 2465 and 2566 are 2466 are the threads which are created. So they were all alive when before I could managed to give this command to get all the threads belonging to this 2464. It is printing its own main thread as well as other two threads. Okay, now if I type it, nothing will be there. Okay, because sorry, this is still running while one. So if I terminate this guy, then it's also gone. Okay, 2464 is also gone. I hope this is clear to you. This is how you have to debug your code, and I hope that this thread and process related things and how pthread create and pthread join is well understood in this lecture. Bye bye, see you in the next lecture.